Hello, so in this video we will discuss third part of first unit mass and weight. Hello, so in this video we will discuss third part of the first unit mass and weight. So let's start with mass. What is a mass? So mass is a measure of the quantity of matter in an object at rest relative to the observer. Now here it is important to mention at rest because when the object will be moving, then there will be change in the observed mass. So if observer is at rest, then the quantity of matter is mass. More the quantity of matter, more will be the mass. Now to understand the concept of weight, let's consider this example. So a ball is dropped from certain height and using a camera, different pictures are taken at regular intervals of time. Means each picture is clicked after let's say 10 second, 5 second or 0.1 second. So time interval is same, but we can see initially the distance between the two, this picture is less, then increasing. Slowly this distance is increasing. What does that mean? In same interval, ball is covering more distance. Means speed at this point v is greater than the speed at this point u. This means कि with passage of time, speed is increasing. And when speed is increasing with time, we say object is accelerating. So this means this ball is accelerating when it is dropped for certain height. Now from Newton's second law of motion, we know that F force is given as force F is equal to mass into acceleration. Now if this object is accelerating, so there must be a force acting on the object. So in this case, what force is acting? So gravity is pulling the object downwards, or gravity is pulling the object or the ball downwards. So the name given to the gravitational force acting on an object that has mass is its weight. So what is weight? Weight is the gravitational pull of the earth. And it is, since it is force, so it is measured in newtons. Now, if you consider any object, so if an object is of mass 1 kg, then the earth will pull it with a force of 9.8 newton. So we can say its weight will be approximately 10 newton or 9.8 newton. Now, if earth is pulling an object and it is accelerated, then the name of the acceleration is acceleration of free fall. Means when an object is dropped from a certain height and it is falling under the effect of gravity only, no other force is acting. In that case, acceleration is known as acceleration of free fall or acceleration due to gravity. See, acceleration caused by the pull of the earth's gravity is called acceleration due to gravity and acceleration of free fall. And it is approximately 9.8 meter per second square near the surface of earth. As you will go upwards or we will go into depth, the value will change, it will decrease, but near the surface it is 9.8 meter per second square and it is denoted by symbol G. Now we will discuss about gravitational field strength. So as we have discussed here that each 1 kg of the mass has weight 9.8 Newton. So 2 kg mass will have weight 2.2 into 9.8, 19.6 Newton. What does that mean? If you want to find the weight, you are multiplying the mass with a certain number, that is 9.8, that is small g. So W we can write as W is equal to mg. So from here, if we want to write g, we can write g is equal to W by m, where W is weight and weight is the force experienced, m is the mass. So force experienced per unit mass is called gravitational field strength. So if for gravitational field strength, we can write Newton per kg. Newton per kg will be the unit. Let's differentiate mass and weight. So mass is quantity of matter, it is measured in kilograms, and weight is a force, it is measured in newtons. Mass tells us about how much matter an object is composed of. Gravitational force uh, tells that the with how much force is acting on the object. Mass is a scalar quantity, weight is a vector quantity. Now, let's consider an object on the surface of Earth, and when you take it on the moon, so weight on moon will be less than the weight on the Earth. Why so? Because on moon gravitational field strength will be less. Gravitational field strength will be less on moon, so its weight will be less on moon, but its mass will remain same because mass is the matter in the composition, and composition is remaining same, therefore mass will remain same. Now consider this example, you are measuring some weight using this balance. So when we use this, we assume that ki same weight, two objects have same weight, it means they have same mass also. Okay, this balance or weighing scale we use to measure weight. But when it is written gram or kg, when it is written gram or kg, if the scale is gram or kg, then this will tell you about the mass of the object. Means we will find its mass, we will not find its weight. So only this much is there in this part. So thanks for watching the video. Share this video with your friends. If you like this video, uh, please subscribe my channel. Thank you.